Cool. So today, we're going to be talking about Cybersecurity Awareness Month. I didn't know until this month, but October is Cybersecurity Awareness Month. So that's the topic today for GDG Cloud Boston. And 1 second about myself, I'm Joe Lust, and I work at Maple, where I'm an engineer. If you didn't know it, we're all on GCP. Today, do intros, news and updates, upcoming events. I'll talk more. Actually, we won't have the survey at the end. But since we already had intros before we started recording, we'll just skip to news and updates. Well, one quick thing is if you're watching, this is GDG Cloud Boston, or the Google developer groups. And, we meet monthly. We had been monthly pre-COVID. We're getting back to it now. And this great picture here is of Cloud Run. Cloud Run had an event, the Google service, where we all ran and they gave us swag. Hopefully we'll have another event like that again soon. You might notice some other folks in the call here. We've got Lucas from the Broad Institute, as you know, myself, and then Norbert, Bigquery expert. And, we try to keep, everybody in line, keep it to be a place where everybody's comfortable to learn and share. So that's our code of conduct there. If you have any questions, please just check it out. If you don't have time to read it, you can summarize it. It's just be a nice person. Don't be a jerk. We want to be respectful and constructive so that we can all collaborate and, foment a real great learning environment. And we do encourage folks to participate. So in that sense, if you have questions, just shout out here and we can address them, as the presentation goes. And obviously, we wouldn't be having this sort of event if people, hadn't joined the group on Bevy, if people didn't show up. So thank you guys for coming out tonight. I was trying to think of news and updates since it's been a long time. So these are just a few things that came to mind to me. And GCP, I'm sure all of you are aware of many other things. But since it's a security talk, I wanted to mention that secret manager or cloud secret manager in GCP, it now actually has a lot more integrations with different services, with cloud functions, with Cloud Run, ways that you can just have secrets automatically injected into your apps. It's a great tool. They've been bringing a lot more features to it lately, so you should definitely check that out. Another thing we'll talk about later here, but service accounts now can be changed for almost every service in Google Cloud. That used to be a challenge, but now you can. That really is going to let you, kind of clamp down and have the best, least privilege access you can do. If you don't use the Cloud Code Editor, it's really awesome. You can do even more fancy code editing interstitially, like right there inside the Cloud Console. If you use Cloud NAT, I don't know if you use that, but it has another security overture here. We don't want to make everybody in our VPC, in our virtual private cloud, available to the internet. So we use a NAT, and that can really help us, a network address translation gateway. That came out a few years ago, but now they've really started to backfill all the missing features, and it scales even better than before. And I'm sure Norbert's aware of this, but now if you use Spanner and Bigquery, you can query one from the other, which is just kind of mind-blowing, which really lets you, use all your databases together, this unified universe of data, which is really awesome. So I'll just pause here for a second for Norbert and for Lucas. Are there any other neat new features that come to mind to you guys that are worth a shout out?
I like your first one there. I wanted to dig on that just a little. The secret manager, when it first came out, it was just basically a place where you could store some secrets and then retrieve them later. And it was pretty sweet and easy to use. And a lot of the other stuff that you might need to do when you're dealing with secrets was kind of, you could do it, but you're on your own to kind of figure out how to get those things done. Now you can set rotation schedules in there. You can set up pub/sub notifications for those things. You can have cloud functions that receive a notification that your secret needs to be rotated, and then that cloud function can go rotate the secret and update your app. And so I think they really made it easy to do all the best practices that you need to do when you're trying to manage secrets, like built into the application directly. So those new features, I saw some of them coming out. I was looking at the G-Cloud client updates, and I started to see some new fields appear in there, and I'm like, oh, that looks like it would be really useful for rotating secrets. And then sure enough, that's exactly what they've been doing. So those have been great. I've spent a lot of time in the last 6 months working with like Cloud Functions version 2, which is basically the new layout for Cloud Functions, where it's kind of running on top of Cloud Run. And so it gets to take advantage of all of the different event sources that Cloud Run can handle. The instances can run for much, much longer. You can have 16 gig Cloud Functions that can run for an hour. And so that's been pretty exciting, as well as another tool that I've really dug in on a lot is workflows, cloud workflows.
Oh, yeah.
And basically orchestrating a bunch of serverless things, so you can have some App Engine apps and Cloud Functions and Cloud Run instances and other HTTP services, and you can sort of string them all together. So you call the first one, and then it gets some output, and then you send that output to the second one, and then you go through a loop of results and execute more functions. And they're getting to the point where soon you'll be able to visualize that whole workflow in the same way you might look at, like a workflow in Lucid Shard or something like that, to see like which functions are calling which functions and which output they're sending and what's being transformed and manipulated. So that's just been a whole new thing that I've been spending time with. When I first started doing serverless, it was like what was missing, and now it's kind of all starting to come together. So it's been a lot of exciting stuff there.
Cool. And I think you kind of touched on the fact that we could spend an hour and a half talking about all the new stuff in the last year. They really, kind of cranked up the rate of new features.
Yeah, I would just, on day to day, I just use BigQuery, and mostly really just the vanilla features or the standard features. But one thing I'll just call out, you no longer have to put backticks around the project name, which is one of the biggest annoyances. It's such a tiny little thing, but it's really super annoying. We don't have to do that anymore. And I convinced the standards group at Wayfair that we could drop the backticks from our production code. And so that was like, okay, good. But I did notice BigQuery has improved the federated query quite a bit. So you can, from within your BigQuery job, you can now query to MySQL instance or Postgres or whatever. Is that, Joe, do you know if that's the same way that the Spanner integration works, is through federated
Yeah, it's
query?
the same way that Spanner. Yeah, I think that it
cool.
truly is a data lake now. You can just pull everything in there.
Yeah, I haven't actually used those features, but I've noticed that they've been improving that a lot, and I think that that data lake emphasis or data platform emphasis is where they're going with this whole thing. So definitely cool, keeping up with the marketplace.
Awesome. And then, of course, with BigQuery, they've added tons of new functions like GIS and all sorts of new methods and math functions. They've added all sorts of security. You can like encrypt each row differently. You can say people can see this row or this column, and all sorts of like really fine-grained features in there now.
Yep.
Awesome. Well, I don't want to spend too long on the slide, so thank you guys for the contributions there. As you can see, tons of new stuff. So I'll just keep on rolling here. Second. Oh, okay. Sorry, I thought it was frozen for a second. That slide's out of date, so I'll skip it. Obviously, what big thing happened earlier this month? Cloud Next 2021. If you didn't see what happened there, it's all online. A lot of great talks, a lot of those great announcements, a lot of the features that we just mentioned. So if you're really into GCP and Google Cloud, definitely check out what happened at Next 21. I know I need to I need to catch up and go and rewatch all of that. So now for the main talk here for the Cybersecurity Awareness Month. Again, I'm Joe Lust. You can follow me, Lust Coder. I'm an infrastructure lead and an engineer at Mabel. So here's the crux of today's topic. It's Cybersecurity Awareness Month, and there's more people breaking into people's stuff than ever before, right? And so, I think we all should ask ourselves, I thought my cloud was secure. Is it really truly secure? And if we think about it, as we move to the cloud, it has pros and cons, right? In the cloud, we get consistent APIs to do everything, right? There's no more like tribal knowledge or having to go ask Bill how to do something. There's an API and there's docs, and that's great. but that has a con, right? If I lose my API keys, some malicious actor knows exactly how to work in my cloud. So I got to be really careful about those keys. The cloud, again, can give me one-stop security in a lot of places, just apply my configurations. But I also need to make sure I apply them right. It gives me one stop to mess up and not apply, my settings correctly. So you have to be careful about things like that. And, beyond all that, you get great audit logging in, the cloud if you turn it on. And a lot of it's turned off by default. And, finally, you can automate everything with these APIs, which is awesome. But an attacker could also automate completely their attack and their ransomware view. So these are all the yin and the yang. We make a lot of things easier, but it means the good things are easier and potentially the bad things are easier. And we really have to be careful about, how we secure everything in that case. So what should I secure? I tried to boil this down to just a few things, and I'm sure everyone has their own view of this. I came up with 4 that I wanted to go into depth with tonight. I wanted to have 6, but then, we all have to go home and eat dinner at some point tonight. So I tried to keep it just at, 4 areas in GCP that you can easily, secure yourself more. And those that came to mind were networking, storage, authentication and authorization, and your services in general. And so, I'll try to kind of jump into, and unpack those things individually. So if we think about the network, because that's how we get to the cloud, right? If there's no network, how can someone abuse your cloud? How can they get there and do things? Well, actually, there are ways, but let's just start with the network because it is kind of the moat we can put around our assets. So, we have networking best practices, right? We can restrict who can actually get to all your virtual machines in your clusters. The good way of doing this would only let in people you want, right? If you really ask your security or your legal team, the best way is to let nobody in, to air gap, but that has a lot of challenges. Obviously, there's a lot of things we can do with firewalls and proxies and other features. And let's dig into what exactly those look like. I did mention, in the description of this talk, gotchas. And this is actually one kind of challenge with GCP I want to mention because, if you start out in GCP, there are a lot of defaults, and these can sometimes be surprising. They might be not exactly what you thought. And that's where you might not have realized that default network that's inside your VPC when you make a new project, it's pretty much open to the world. Anybody can ping your computers. And the thing that's kind of scary is anyone can SSH in and anyone can RDP in to your Windows machines. I don't know about you, but this kind of freaked me out the first time that I was doing this because, I remember reading about a Linux attack, where someone could kind of basically knock on the door 3 times and break into your Ubuntu machine via SSH. And I said, well, of course, nobody can SSH into this little toy project of mine. And then I went and I looked and I saw that there's a default SSH, all IPs open to the world. So, you really need to watch out for this. And I know some people might say, oh, who's out to get me? Well, there are port scanners. And this little play project I had, I went and I looked in the logs of SSH, the auth log, and I saw 8,000 failed attempts to log into this machine. 8,000 failed attempts. So if you have something on the public internet with a public IP, people are going to be hammering on it all the time. Most of those attackers are kind of doing, not very savvy attacks. But, if there's a 0-day or a new exploit is announced, you could basically, be ransacked very quickly. So be very careful about that. And the other thing to keep in
I'll
mind
just
sorry, go on.
Jump in here. A little tidbit on this one. This has been at the Broad. We've been using GCP since 2012, and this has been a concern from the beginning. Like the #1 issue that our InfoSec team has been stressed out about regarding our GCP cloud. And today, after many years of discussing, today at noon, I implemented the org policy on our org, which disables the creation of the default network for all new virtual machines and all new projects. So as of noon today, when a new Brody creates a project and then they enable compute engine, it does not have a network and they have to manually create a network. But we no longer have the open port 22 and 3389 anymore on any new projects.
Okay, so I was afraid Lucas was going to tell me, Joe, they changed that feature today. And I'd be like, no.
No, we implemented it today.
Gotcha. Okay, you implemented it. Yeah,
we implemented this org policy.
Yep. I didn't touch on org policy. I had that later in the deck. But yeah, org policy is an amazing tool where you can say, nobody should be able to make a public IP address for a VM. Nobody should be able to make this kind of network. Nobody should be able to make a public bucket. And then it becomes impossible for this to happen, right? You don't have to wait like, check the logs to see if bad things happen. You can basically say all these things are impossible. And that is the ideal, definitely. The other thing I was just going to note here is there is also a rule that lets access to the internet for everything by default. And finally, there's a rule that says all the, the 10 dot, the RFC 1918 block, all your machines can talk to all your other machines, which means there's no segmentation at all. So this is great for getting started. This will just work as a sample project, but as Lucas points out, it's really not the way to run an enterprise. So what are some of those best practices we can bring to bear? As Lucas just pointed out, don't use the default network. Make a new one and make just the one you need, because sometimes the default network will make tons of subnets and a lot of stuff, those firewall rules that you don't need. I would generally suggest only opening up the ports that you want, which might not be very many ports at all. And another thing is not to have public IP addresses. Luckily, most tools now in GCP, you don't have to have public IP addresses. If you spin up a Kubernetes cluster, it can be totally private, for example. And when you don't have a public IP, people can't get to your machine, at least not easily, not by default. So, you should really consider, do my machines need to talk to the internet? If you're not hosting a web server, maybe they don't. And PGA, or private Google access, is a way that you can say, I'm going to make a network like a VPC or a subnet, and it can't talk to the internet, but it can talk only to Google services. So maybe I need to take screenshots and read and write them from a bucket. I can put them in a subnet, give it private Google access, and it can talk to nothing else in the world. And so now, you seem that you're much more secure because you've kind of battened the hatches. Another just amazing tool that I don't know why we don't hear people singing from the rooftops about is identity aware proxy. It's amazing. Google Auth is like one of the most secure things on the internet, right? Don't roll your own auth framework. Take the fact that in, Sunnyvale and, in San Francisco and Mountain View, there's like, hundreds of PhDs trying to think of the most secure way to let somebody log into something, and use that. It's the same auth you use to log into Gmail and your other tools, and you put that in front of your application. So now, for example, if you want to RDPN or SSHN, you just do gcloud, gcloud compute instance SSH, and there's a / tunnel through IP.
They dropped that instance at some point, so it's just gcloud compute SSH finally.
Finally, awesome. We got Mr. Know-It-All here. Yeah. But anyway, this is an awesome thing, because now those VMs aren't on the public internet, and they have to authenticate as one of your engineers at your company. And if you're like our company at Mabel, every engineer has to use a Titan key. So in order to even become an engineer, to auth, to then log into a machine, you have to use a key. And now that is like so many thousands of times more secure than the old-fashioned way of putting a machine on a public IP on the internet, exposed to port 22. And there are other great tools out there as well, like Cloud Armor. And you can find a lot of code labs at that link there. We'll put up a link to the slides here on the listing for this talk afterwards. Another great tool just to think about networking is network tags. When you launch a virtual machine, you can put a tag on that virtual machine. It's just a string. And now you can apply firewall rules and routing rules based on that tag. So you can make a group of machines. Say you make a node pool in a Kubernetes cluster, and you get the same tag on all of them. And now you can just say, you know, cluster B can route to cluster A. And you don't have to know the machines. You just say, you know, like GKE-A, GKE-B is your tags. And you say in the firewall rule, they can talk to each other, and it just works pretty much magically. And, you know, that can also be really useful as a way to kind of, you know, further refine clamping down on machines. You know, maybe before someone can IAP into a machine, if it's a really, you know, lockdown, you know, network, you could say it has to have the IAP tag on it. And now you've kind of got belts and suspenders. But network tags make it really easy to you know, segment within a subnet or a network different machines that can only talk to each other. Really awesome tool.
That will also work with auto scaling, right? Where you don't even know the machine IP address in advance, right? So
yeah.
if your auto scaling group adds a couple more machines, boom, they're going to work out of the box.
Exactly. And that's kind of, you know, the whole vein of like cloud thinking, right? The whole idea of like cattle, not pets. Like, I don't even know what these computers are named. I don't even know what their addresses are. They come, they go, but the tag, you know, it's a way that you can have an identifier on all those machines. As you mentioned, managed instance groups on just, you know, regular cloud instances, on clusters, things like that. So that in a nutshell is just ways you can think about securing networks. You can probably go and get a certification in all the details here in GCP. Won't get that deep, but these are some just really simple things that you can do to clamp down on your networking to get you much more secure than the typical person. So the next thing I wanted to talk about was securing services. And by services, I want to highlight the fact that when you go into the cloud, it's not just hard disks and computers that you're getting. You know, you're getting access to APIs and other services, which can potentially be, you know, very far-ranging in scope and very expensive. So, you know, GCP has tons of services that are just APIs, just like Amazon. You know, hundreds of APIs you can call. But some of them can be really expensive. You know, I'm sure Norbert knows all about, and so does Lucas, about Bigquery, right? You know, well, if I could get access to your Bigquery API service, I could then query some other data somewhere else and run up a gigantic bill, thousands of dollars. You know, I could do something to mine crypto, things like that. So if I'm a malicious actor, if I get access to your services, forget about the network, forget about your machines, I can run up a huge bill, you know, I can do malicious things. And so you really need to be careful who can get to your services. Ideally, it's just your apps and your engineers that can talk to your services. So we need a way, you know, to clamp those down and secure them better. Some gotchas, and I'm sure maybe Norbert or Lucas have some more gotchas, but, you know, some APIs are enabled by default. And so you want to be sure, you know, you turn off the services that you're not using, right? Because if someone got your GCP keys, then they can abuse it. So you just want to be careful, you know, when you've got your projects to know what's actually turned on. Luckily, not much is turned on. So that leads to our first, you know, notable best practice with all the APIs and services you use in the cloud. I say MV services, minimum viable services. You know, if you're playing with something and you turn on a service, turn it back off when you don't need it. If you spin up a new project, you know, only turn on the stuff you need. If you don't need to run compute, don't turn on compute, right? Now somebody can't launch Bitcoin miners because you never turned on any runtime services. So as an example here, you know, when you go to use Bigquery the first time, you'll see it pops up and says, do you want to enable Bigquery? So this is just a best practice where you should only turn on the things that you actually have a business need for. And if you're not really needing them, you know, just turn them back off. And now they can't be abused because they're not there. Okay, well, I misspelled this one. This should say perimeter. Excuse me. Another great thing that Google has launched is they call service perimeter. And this is for the most paranoid, locked down way to control your services. The idea here is, you know, what if someone somehow stole my little key here and they stole a service account or something like that, and they could still access my Google APIs. Well, with service perimeter, not parameter, sorry for the typo again, what you can do is say, this VPC network can only connect to this project's APIs and only to these APIs. So now only if your code is running inside Google Cloud in a specific place can it even call the BigQuery API on your behalf, right? So if someone stole your key and they're running out of Russia or, you know, Phuket or wherever, they cannot even connect to that API and abuse it. This is kind of like the most locked down mechanism. It doesn't even matter if your keys are lost. The true belt and suspenders. So, you know, maybe not everybody uses this because it makes development a little harder. Like, how do I do it from my laptop? But it is, you know, the most secure way to lock down services. I'm curious, Lucas, do you guys use this at Broad at all?
Not exactly. In Terra, I think we use it to some extent for the management of the Terra application, for the service, like the backend services that you use to administer the application.
Gotcha.
But what Broad did, you know, even before this service existed, was we did like, instead of having SSH be open to the world, we would have SSH open to a set of subnets that restricts it to the Broad. And so the implication there was that in order for me to get to this VM in the cloud, I first have to be able to get into the Broad's internal network, and then I can get to the VM in the cloud. But as you pointed out, I mean, that's great from a security perspective, and especially when you're still an on-prem company and you're thinking about things in an on-prem kind of way, that makes sense. But when your on-prem network goes down and suddenly you can't administer your cloud network anymore because your on-prem network is down, that's kind of annoying. And so I think we've reduced the reliance on that capability and added more things like the IAP, which is like, instead of having SSH open, you know, you have people logging in through the IAP or using a tunnel. And so there's some things like that we've done instead. I think we're so early in our real security posturing that, like, literally the first org level policy that we installed was the one today to disable the default network. I also want to turn on the one that like enables OS login, because then instead of you being able to log in with any old SSH key and any old user on any old VM, it would actually use our Broad user IDs and home directories and so forth, which we've pushed into the G Suite environment. So everyone in the G Suite environment has like a UID and a GID and a home directory. So when that same person logs in with OS login to a VM, they have the same UID and home directory that they would have in the on-prem environment. Their identity is the same. And so it allows you to lock down the machine more than with the normal, without OS login. Anyone who's an editor can like log in and become sudo on the machine. And so this gives you much more control over who can actually log in and do things and what permissions they get when they do log in.
Definitely. I think you raised a great point there of kind of like an old versus new view of security and networking, right? Because, you know, I think you could probably say that the IAP way of doing things, that's more consistent with like kind of the beyond court model, right? Because if you had to go to the service perimeter, well, now I have to get my engineer away to get from their laptop into that VPC, which you could almost argue is less secure.
Yeah, I mean, there's certainly the security is always this constant battle between, like, yes, you want to make it more secure, but the most secure version of any service would be one that's not accessible at all.
Exactly.
And so you do need to deliver services, so you have to find some happy medium there. I think when we're starting to dip our toes into the cloud and our whole world is on-prem, to make a statement like, oh, let's behave the same way we did. Like, the only way you can get to these database servers is if you're on the internal network. So if we're going to spin up some servers in the cloud, let's just make it so you can only get there from the internal network as well. But then as you start to become more of a cloud company, you know, you don't actually want to have that reliance on the internal network anymore. You like the separation because one goes down, the other one isn't down. And so having them depend on each other becomes a little problematic in that respect. So yeah, I think Beyond Core is more our style now. Like, if I were deploying a new service, I wouldn't put it on the internal network and then require you to connect with the VPN in order to get to it. I would put it in an App Engine app, and I would require you to log in with your Broad account in order to access it. Because your Broad account is going to not only require your username and password, but also your 2FA. And so you know, there's plenty of third-party apps or custom apps that we've built where you had like custom authentication in there. And then you get to this new world where 2FA becomes kind of critical in all respects. And you're like, well, how do I get 2FA into this app? Well, like you said earlier, you don't worry about it. You let Google handle the authentication.
Exactly.
And then, you know, you let it, once the user has successfully done that part, then they can talk to your app, but they can't even get to your app before that. Like, that's the great thing, is instead of like with the SSH model, you have someone brute forcing the actual port 22 on your machine and trying to authenticate. With the IAP model, they're brute forcing the proxy server, and like that never even touches your service. It's only a fully authenticated connection that actually ever gets through to you. So you're like just sitting back and waiting for legit connections instead of fighting off all of these illegitimate ones.
Definitely. It's very much the cloud model. Just outsource that problem. Awesome.
Exactly.
Well, let me just move on here. Don't want to harp on this too long, but thank you for adding the color there. So that was services. Again, only use the services you need and lock them down as much as you can so they can't be abused. Another area is storage. Obviously, we're storing data in the cloud. Maybe you got screenshots. Maybe, you know, you've got customer records, whatever it might be. We've got to make sure that, you know, only the right people can see the right things there. So I'm going to pretty much just talk about buckets because they're kind of like the most misconfigured thing in the cloud. Obviously, if we want to talk about storage, there's many other areas of storage that can be considered. You know, there's disks, you know, there's all sorts of databases and things like that. But just to keep it simple, I'm talking about buckets here. And some of the gotchas you might not realize is that by default, you know, your buckets, and by buckets here, I'm talking about Google Cloud Storage buckets. They can have, you know, mixed policies. And by mixed policies, I mean that you can say that this file can be accessed to everybody in the world and these other files can't. And that kind of makes it hard to reason about, because what if you have billions of files? Do you want to go inspect billions of, you know, access control lists? It kind of becomes unwieldy. And more importantly, if somebody hacked into your cloud, they could just go and change a few different access controls on a few files, and you'd have a needle in a haystack trying to find it. And they'd be easily able to pull those private files out of your cloud now. Another gotcha you might not realize is that it's, you know, really easy to delete the stuff in your buckets. And I don't know about you guys, but as an engineer, you know, invariably someone comes to you and says, I didn't mean to delete all that stuff. And most, you know, most deletion concerns are actually not because of a malicious actor, but because of a, you know, misintended actor. Someone was trying to do the right thing and it didn't work out the way they thought. So these are two gotchas that a lot of people don't realize by default. And they're really easy to remedy. One is you can make your bucket non-public. Now, we heard earlier about organization policies. I believe there's some policies for this. So you don't have to worry about an engineer accidentally making a public bucket. So in this case, though, when you do have a bucket that you make, you can go in there and there's just a checkbox. If you go into the Cloud Console, go into storage, click in your bucket, and you can just say, this is not going to be a public bucket. I don't want these things to be accessible from the internet. And that prevents a whole host of accidents. Because most people don't realize it, but every time you see in the tech news that like 60 gigabytes of, you know, loan applications were found on the internet, or 100 gigabytes of, you know, student records or medical images, almost all of them, all of these cases are in AWS S3 bucket that was accidentally set to the default public state. It's you know, it's such a problem that now if you're in Google or if you're in AWS, they actually pop up and they just yell at you, are you sure you want this to be public? You know, so be very aware of that. And when you make a bucket, it's just a single checkbox. Just go in there, click non-public, and it's perfect. You know, no one's going to be able to see what's in there. Another important thing to think about is the uniform bucket level access policy. I think this is like the most poorly named thing in Google Cloud, because you're always like, what's the UBLA? And if you read the docs, it's rather confusing. But in a nutshell, the value here is you're saying that all access must be via a consistent set of ACLs. Like I have given, Jim access to this or Sarah access to this via IAM. And you can't just start like making things piecemeal public and not. And again, this really helps, reduce the exposure of either a malicious actor trying to kind of exfiltrate data, or someone just accidentally applying, the wrong policies and making things challenging to understand. And this is also just a checkbox. You go into your Cloud Console, storage, click the bucket, check the box, and now you get this uniform policy. I think there is a limitation though. After 90 days, you can't undo it. So keep that in mind. And finally, I think this one is really the most valuable feature that people don't think about, and that is retention policy. So let's say you've got backups, right? We've all got backups, right? And somewhere in GCS, we have something called like, Acme Co backup bucket, right? Well, what's the worst thing that can happen when you've got a problem, right? You go and you look in your backup bucket and it's empty. And you think, oh my goodness, where are my backups? I don't know if you ever heard about the outage that GitLab had several years ago. They hosed their production database. They went to the storage bucket with the backup and it was empty. That is a problem. And one thing you can do with a retention policy is you go in, same panel, same console in the Cloud Console, and you say, I have to keep everything in this bucket for N days. So maybe you have an actual regulatory requirement. Maybe you have to keep documents for 7 years, something like that. Maybe you just want to hang on to your backups for 90 days. You go and you put that in there. And now that file cannot be deleted. If you go in and you send an API call, or you go to GSUtil in the command line and you say delete it, it says can't do it. And the really valuable thing here is there's another bit you can set which says make this irrevocable. And after a few days, it can't be undone. If your CEO calls, the CEO of Google Cloud and says, delete this, it can't be deleted. Like it's built into, all their software that once that's set, it can't be undone. And this is really valuable because if you have like a script that goes wrong, it can't delete data, no matter like what privileges you have, it can't. And most importantly, we keep hearing about ransomware attacks, right? Well, what's a ransomware attack going to do? Well, if they're going to encrypt all your data and charge you for the key, they're also going to delete all your backups or get rid of your backups somehow. Well, if your backups are set with a retention policy, they can't be overwritten. Someone can't take them and encrypt them. Someone can't take them and delete them. So now you can't lose your data accidentally. You can't lose it maliciously, and it cannot be undone. Like that data will have to sit in that bucket for 1 year, if you said 1 year, and that's the only way it can ever be deleted. So a really amazing security feature. So that's just in a nutshell things with buckets, but think about how like you want to control, making sure your buckets can't be public, making sure that they can't have confusing or easily misconfigured or maliciously misconfigured access policies, and then making it so it's impossible for you to lose data that you never want to lose. A final piece here I really kind of wanted to get into is what I was considering securing auth, or securing your authorization layer. And when I say auth, I'm thinking of IAM, or Identity and Access Management. In Google Cloud and in GCP and everywhere else, it's called the same thing. And it's really important because, if someone can, sorry, let's just say pretend, if somebody can pretend to be you, then, that's the ball game, right? If they can pretend to be the administrator in your cloud or to be a service worker, then, you've lost all that security. And, what happens if you lose a key, right? If somehow you take one of your, JSON file service account keys and you post it to public GitHub by accident. Well, this happens all the time. And believe it or not, there are bots that listen to like every commit to every public repo. And you can set this up easily in GitHub. And if they run regular expressions, and if they see that key go by, they grab it. And remember we said in the opening slide, things are easy to automate. They're well documented. So there are places out there that, the second that you take a key, you post it to GitHub publicly, a few seconds later, they're going to grab it. They're going to, figure out how to log in and just start launching Bitcoin miners, things like that. Like this is out there. So it might sound like, oh, how could this be a problem for me? I encourage you, go and take some of your keys, post them to GitHub, and see how long until things start happening. And that's why, it's really important that we secure our auth as much as possible. And, beyond that, there are other cases you can consider, like, I don't know if you heard about the NPM hack that happened on Friday morning. And if you had updated some of your code, a script was run on your laptop. And if you had Windows, it would dump all the keys in your system, all your credentials, all your cookies, all your environment variables. Well, if you were an engineer, it just stole your keys. So just keep in mind, we've got to secure these. So in that case, what can we do? Well, to start with, we can be careful of the gotchas in IAMs. The biggest gotcha, I think, in GCP is there is a compute service account, the default compute service account, which is going to be named something like compute at, and like, the name of your project. And there's the app spot, which is, I think, like app spot at in your project service account. And they are editors on your project, which means that they have thousands of roles, thousands of permissions. And many people don't realize, if I just go and launch a cloud function and I don't specify anything, what's it become? Well, it becomes the second highest role you can get. So that's kind of scary. And of course, as we mentioned, if you have a physical key, they can be lost. And a final gotcha many people don't realize, it's a feature, not a bug. You can read about this online. People have talked about it a lot. Is that when you launch a service like Cloud Run or a Cloud Function, and you launch it as a specific service account. Let's say I have a function called, what's my IP function, and I wanted to use what's my IP at blah, blah service account. Well, I have to use a certain role in IAM that's called basically run as. So I have to say that I have the right to launch something else that's going to be somebody else. Okay. And I know this is kind of inception, but here's the rub. If I can launch a service to run as a different service account, what if that service account has higher privileges than me? So now I can say, launch some code. It runs as another service account. It has more permissions than I have. And then maybe it could give me more permissions originally. It could do malicious things. So there are a few roles in IAM that let you become somebody else. And it's an easy way to escalate beyond the roles and permissions you were granted natively. And so you should really be careful about those. So the best practices, turn it off. This is a new feature that came out earlier this year, by the way. You can turn off individual keys. So, if you go in and you see a key and it doesn't seem like it's been used, and I know I don't have a picture for you, but if you go into the service account dashboard in the console, you can see each key and you can see the statistics for when it's been used. So if there's a key and no one's using it, just turn it off. And if your ops genie alert starts going off, then you can turn it back on, right? It used to be you had to delete it, but now you can just turn it on and off. And the same goes for a service account. If you see a service account and nobody knows why it's there, if it's a vendor you haven't used in years, disable it. And if someone complains, you can turn it back on. But at least now, you don't have to worry about, those service accounts or those keys causing problems. You can just easily turn them right off. And as mentioned, there's tons of metrics in there now. There didn't used to be, but you can go in there and see them. There's also a great tool which shows you everything that service account can touch. So I should have put some screenshots in here now, but you should just always be auditing your service accounts and turning off everything you don't need. A major suggestion I would have, though, because I keep mentioning losing your keys, don't use keys. Go keyless. And this is becoming easier and easier to do with Google Cloud. I'm sure everybody here back in the day, and by back in the day, I mean 3 years ago, you went and you exported a service account key, and then you took that key and you put it into a secret in Kubernetes, and then you brought it back into your Kubernetes job, and you had to become that user. Well, you don't need to do that anymore. For the last 2 years, we've had workload identity. So when you say run a pod or a container, a Docker container in Google Kubernetes engine, you can say run that one as Ini, run that one as Mini, and run that one as Mo. You can run it as different service accounts, and we don't need any keys. And if we don't have keys, we can't lose keys. We don't have to rotate keys. So I generally challenge you to say, do I even need any keys at all? And the final thing to think about here is most things running in Google Cloud, most runtimes, they have a metadata server. And that metadata server, it's on a localhost port, It's like, I don't know, .152, something like that. It's like internal.google, local.internal.google. Well, just Google it. You'll get the exact string. You can call that, and it will tell you all about yourself. It will tell you what service account you've been told to run as. It will give you a temporary OAuth token. And so you can use that OAuth token to call Google services. You can also use that OAuth token to talk back and forth to other services. There are libraries you can use to do that. And that means that nothing that you're sending into the cloud needs to have Google Cloud keys. Everything can just run as the service account. And so again, you don't need to rotate keys. You can't lose keys you don't have, and your life gets a lot simpler. So I'd really encourage folks to try to go keyless if they can. And a final thing in here to consider is to have per service accounts. We all know, the principle of least privilege, right? That says that we should only let our computers and our services and our tools do the bare minimum that they need to do. Well, then in that case, only have one service per service account per service. And the neat thing about this is, let's say that you're launching that notional cloud function I mentioned a minute ago, the one that just says, what's my IP address? Well, that doesn't need to do anything, right? It doesn't need to talk to any other service or to get files. It doesn't need any rights at all inside of Google Cloud. So you can make a 0 role or an empty service account. I know a lot of folks that have a service account that's called like the no role service account. And then they put that on their cloud function. And if somebody compromised your cloud function, what's it going to do? Like, the blast radius is just that running instance now. It can't get anywhere else. It can't abuse any of your services. And, should be noted that almost every service in Google Cloud can now get an individual service account. That default compute user and that default app spot user, you don't really need to use those anymore, because now, data flow or app engine, Cloud Run, Cloud Functions, all these things can be given a specific user to execute as. That wasn't always the case, but it is today. So you should really, again, use one service account per service to enforce the principle of least privilege. So that, in a nutshell, is a cacophony of things you can do. If you're interested in more resources, I'd strongly suggest you check out Google Cloud Security Best Practices Center. There are so many best practices. They don't have a web page. They have a center. Definitely check that out. There are some code labs out there for setting up App Armor, for example. If you want to find a way to put, a protective barrier in front of your services, you can go and use those code labs. And there's some other great blog posts I've linked here, GCP checklists, just things to make sure you do when you set up like a new project or you're creating new environments, to keep them locked down and put in place, best practices. And I don't have a link right here, but I should, to mention the organization policy, because it really is a great way, as Lucas mentioned, to cascade from the top down, all the best rules and have them be automatically enforced. So that is our quick how to lock down your GCP project tutorial now for Cybersecurity Awareness Month. I wanted to thank you all for listening, and see if there were any questions there from Matthew about the sort of stuff that you're doing in your job and your projects, and if there's anything we can help you address there.